Okay, so thank you for joining the fourth biomarker workshop. And our topic is protein backbone assignment using CCPNMR AnalysisAssign. And first, I want to introduce the biomarker staff to you. And Deb is the director of our biomarker lab. He's mainly responsible for the 600 and 800 AMR instruments that are located in the chemistry building. And those instruments are used for protein AMR experiments. And I mainly work in the Mary Sue Coleman Hall, and I'm responsible for the 400 and 600 megahertz AMR that are used for small molecule AMR experiments. And Emily is our faculty director, and Anne is the director of operations. And I have put our contact information here. So if you have any questions with your AMR experiments, feel free to contact me or Deb. And starting last July, we decided to hold quarterly biomarker workshop. And here is a list of the biomarker workshop topics. And our first workshop is on 1D and 2D AMR methods for small molecules. And this was held in last July. And then Deb held another one on protein backbone assignment, protein backbone dynamics in December. And this May, we have the third workshop on AMR data collection and backbone assignment using Sparky. So for all those three workshops, the videos are available online and you can watch them anytime. And today is our fourth workshop. And in a few months, we'll hold the fifth workshop on diffusion NMR. And in the future, we will do those other workshops quarterly to cover metal AMR strategies for large proteins, AMR approaches to probe intrinsically disordered proteins, dense AMR, relaxation dispersion NMR, residue dipolar coupling, and metabolomics, and so on. And if you have any other topics that you are interested in, feel free to contact me or Deb, and we can add that topic to this list. And now let's move on to our topic today, protein backbone assignment using CCPNMR AnalysisAssign. So there will be two parts in our workshop. First, we'll just briefly go over workshop number 3, and we'll focus on part 1 of the workshop in which Deb introduced the protein backbone 3D AMR experiments. And then we'll move on to have a hands-on session that I'll show you how to do the backbone assignment using CCPNMR AnalysisAssign. So in workshop number 3, there are mainly 4 parts in that workshop. In the first part, Deb introduced protein backbone 3D AMR experiments. So there are several experiments that he covered, and the major 4 experiments are HNCO, HNCACO, HNCACB, and CBCACONH. And these 4 experiments are also the ones that we are going to use today for backbone assignment. And in the second part, Deb talks about how to set up those experiments in TopSpin. And then he covered efficient data collection strategies for collecting those 3D AMR experiments. And then finally, he demonstrated how to do the backbone assignment using Sparky. And here are the 4 experiments that Deb covered in workshop number 3. And the first one is called HNCO. And as you can see in this figure here, the nuclei that you are going to observe in the spectrum are colored in pink. So this spectrum actually correlates the amide proton and nitrogen of the current residue I with the carbonyl carbon of the previous residue I-1. The second spectrum is called HNCACO. And in this spectrum, you can observe cross peaks that correlates amide proton and nitrogen of the current residue and the carbonyl carbons of the previous and current residue. So by comparing the HNCO with HNCACO, you can easily identify which carbonyl carbon cross peak belongs to the previous residue and which belongs to the current residue. And then you can utilize these 2 spectrum to assign the carbonyl carbon and amide proton nitrogen of your protein. And for the alpha and beta carbon of your protein, you can utilize this CBCACONH and HNCACB for the assignment. So in CBCACONH, this spectrum correlates the alpha and the beta carbon of the previous residue with the amide nitrogen and proton of the current residue. And for HNCACB, in this spectrum, you can observe cross peaks that correlates the amide proton nitrogen of the current residue with the alpha and beta carbons of the both previous I-1 residue and the current residue I. And these CBCACONH and HNCACB are actually very helpful in identifying the amino acid type in your spectrum and also to connect the residues. So here is an example. This is also from workshop number 3 that shows how to do backbone assignment using CBCACONH and HNCACB. So we actually do those assignments in straight plots. As you can see in the figure on the right, in the first strip, this is an HNCACB spectrum. And in this strip, you can see 4 cross peaks. The 2 red ones are the positive peaks that belongs to the alpha carbons of the previous residue and the current residue. And then 2 green peaks are the beta carbons that belongs to the previous and current residue. And then the second strip plot is the CBCACONH strip. And in this strip, you can see 2 cross peaks, one from the alpha carbon of the previous residue and the other from the beta carbon of the previous residue. And so you can compare the HNCACB and CBCACONH side by side, and that can help you to easily identify the alpha and beta carbon of the current residue. And then we can actually link those straight plots one by one from one amide group I to the next amide group I+1 to I+2 and all the way to a long chain. So that's a process for backbone assignment. And later on in the hands-on session, I will show you how to actually do this step using CCPNMR. And so the goal of the backbone assignment is that if you have a proton nitrogen HSQC of your spectrum, then after the backbone assignment process, you will be able to assign every peak in your spectrum. So you now know which peak belongs to which residue. And then once you have the assignment, you can do follow-up structure study or dynamic studies or protein-protein and protein-ligand interaction studies. Okay, so that's all for the first part, the summary of workshop number 3. And any questions so far? And feel free to submit the question to chat so that we can see the question and I will answer them. And if there's no more question, then we'll just move on to the second part that we will do the backbone assignment using CCPNMR. And here are a list of software that are available for backbone assignment. And for our workshop number 3, we covered Sparky. And this workshop, we cover CCPNMR. And in the past, I've used AMR Vue.js for backbone assignment. This one is also very good software. And some other users may use Kara and so on. So feel free to explore other programs that you found convenient to use. But for the workshop, we just covered the first 2, Sparky and CCPNMR. And I've already sent you the link to download CCPNMR. And the version we are going to use is the latest version 3.1.0. And since maybe you have already downloaded software, and while you download the software, you can see that on their webpage, they have links to download different versions, Mac, Linux, and Windows. And also they have a video available on the same page, which I found very useful in that they have the video for installation. So if you have any questions of installation, you can watch this video and see if that fits your issue. Another very useful link is this video tutorial and manual on the CCPNMR website. And on this website, they actually have each step, like for example here, for the basic usage, they have a manual for each step of those, how to use the instrument, use the software. And then also they have a video available for each of these steps. And that's how I learned to use this software. So I watch this video. And then if I have questions while working on my project, I go ahead and watch the video again, or I read the manual and tutorial to resolve the problem. And after you install CCPNMR, then there are 4 steps to do the assignment. First, I will show you how to load the spectrum. So load the spectrum and display the spectrum. And then we will do peak picking. We'll first pick the peaks in the 2D proton nitrogen HSQC spectrum. And then we'll pick the peaks in the 3D AMR spectrum. And after peak picking, we'll finally do sequential backbone assignment. So now I will open up CCPNMR. Yeah, hopefully everybody have this CCPNMR installed, and maybe you have tried to open it up and see what it looked like. So when you open CCPNMR, first you will see a drop area in the center. That's where you can drop the spectrum into the area and display the spectrum. And then on the left is a sidebar. In the sidebar, you can change the properties of the spectrum or change the properties of AMR chain, then samples, and so on. And then on the top is menu bar. So now I'll show you how to load your spectrum. And let's go to the ubiquity data file that I shared with you. And as you can see in this ubiquity data file, I sent you 4 AMR, 3D AMR spectrum and 1 HSQC. This is a 2D AMR spectrum. And then a FASTA file, that's the sequence of the protein. And all these spectrum are in UCSF format. That's actually the format that are used by Sparky. And CCPNMR is actually very powerful, so you don't need to convert this format to any other format. So you can directly open UCSF format. It also can directly open Bruker format or AMR Vue.js format. This is very convenient that you don't have to convert the format of the file. And then I will just select HSQC and then drag it and drop it into the drop area. And now this HSQC spectrum is displayed in the drop area. And then I will change the properties of the spectrum a little bit to make it look much better. So first I can move the spectrum around. So I can left click and drag. So I can move the spectrum to the center of the drop area. And then I can zoom in and zoom out. And I just scroll my mouse wheel here to zoom in and zoom out. And if I want to look at a specific region that I'm interested in, I can actually press the shift button and then left click and drag. And then I can look at the specific peaks that I'm interested in. And then I just scroll my mouse wheel again to return to the full spectrum. And I can change the aspect ratio of the spectrum. So if I move my mouse to the y-axis, here I can scroll my mouse wheel again. And then I move my mouse to the x-axis and scroll the mouse wheel. So I can change the aspect ratio. And once I am happy with this ratio, then I will click on this locked to lock this ratio. Okay, and also we can change the contour levels. So if you go to this icon, this up and down arrow icon over here, and then press it, then you can change the contour levels. All right. And if you want to change the contour colors, you can actually right click and click on contours. And in this pop-up window, you can change the color of the contours. And also you can select on this deselect shows negative contours. So the negative peak will not show up in your spectrum. And then click on OK. And down on the sidebar, as you can see now, a HSQC spectrum is loaded. And also you can double click this spectrum HSQC. So that will open up this spectrum properties window. And under the general tab, you can change the HSQC, like the name of the spectrum. And then under dimensions, you can change the dimension properties. Or again, you can go to here to change the contour properties of the spectrum. So I'm going to close this window now. And on the menu bar, and if you click on File, and you can actually save your project anytime. So you do Save As, and then you can save your project. So if you don't have time now to work on the project, you can save it and continue to work on it later. Another very useful feature I find for this is under Help. And under tutorials, so there's a list of tutorials available, including the video tutorials and the menu that I mentioned. And also, if you click on this backbone assignment tutorial, and that will open up a PDF file. So that's a tutorial for backbone assignment. And it's a step-by-step guide for doing the backbone assignment. And what we're actually doing today is just to walk through this whole tutorial steps and do the assignment. And if you're having any problem with your assignment, go ahead and read this tutorial. I'm going to close it now. Okay, so that's how to display the 2D spectrum. And then we can open up a 3D spectrum and see how to display the 3D spectrum. So I'll go back to the ubiquitin data file. And I'll show you another way to display the spectrum. So now instead of just directly drop this spectrum into the drop area, I can actually first just load the spectrum. For example, I select the HNCACB spectrum and I drag it to the sidebar. And now on this under spectrum, you see HNCACB is loaded, but it's not displayed in this drop area. And then I will select HNCACB and then drag it into the drop area until I see this purple box. And then I release. And now this HNCACB spectrum is displayed. And as you can see, there's a lot of noise. So I will change the contour levels. And then I will move the spectrum to the center and also zoom in. And then change the aspect ratio. Right. And also I can change the colors, go to contours. And I'll select red for the positive. And then green for the negative peak. So now this spectrum looks much better. And if you want to move through different planes of the 3D spectrum, so you can click on this arrow here, so left and right arrow here, so you can check every peak. So that's for displaying the 3D NMR spectrum. So now I'll close this 3D HCN module, and we'll move on to pick the peaks in the 2D HSQC. So to pick the peaks, you can press Control and Shift and left click and drag, and then select the region you want to pick, and then release your mouse button, and then all the peaks are picked. And if you're using a Mac, you just press Command, Shift, and then left click and drag. And you see the program automatically pick those peaks, but still there are some other peaks that did not get picked up. So these are most likely due to peak overlap issue. So for those peaks, I'll just pick up them manually. And if I want to pick them manually, for example, I can zoom into that peak I'm interested in, and I just do Control Shift and left click. So that peak gets picked. I will do this for those other peaks. Make sure every peak is picked. And some peaks are very weak. I'll also pick them up. Yeah, I think that's all the peak we need. And once you pick the peaks, and if you go back to the sidebar, click on that HSQC, now you see there's a peak list generated. It's called the peak list HSQC.1. And if you want to check that peak list, you can select the peak list. Again, you can drag it into the drop area. And now you can check the peak table. So that's the peak we just picked. I'm going to close it now. And now we pick the peaks, but as you can see, on the right side of this every peak, there's no number of the peak and there's no atom type. So the next step is actually to assign we call it a residue number and a amide proton nitrogen atom to each of those peaks. So I can go to Assign and click on Set up AMR residues. And I'll just use the default settings. So it will use the peak that we just picked. And for the chain called AMR chain. So I'll click on Set up AMR residues. And now for each peak, the program automatically assigned a residue number and an atom type to it. So it's amide proton and amide nitrogen. And then we can go to actually on the sidebar, we can go to MR chains. And under MR chain here, you can see that's the peaks, all the peak. And if you click on each of the peak, there's a atom associated with this peak. So it's an amide proton and amide nitrogen. So this step is actually very important. And this residue number and amide proton nitrogen atom type that we assigned are used for backbone assignments. All right, so that's for peak picking of the HSQC. So again, if you have any questions, now you can submit to chat so we can work on your questions after this step. So now I will open up those 3D spectrum, and then we will move on to do peak picking for the 3D spectrum. All right, so there's one question. Okay, so we have one peak missed, 9.2. So the question was, there's one peak missed at proton 9.2 ppm and nitrogen 120 ppm. So I guess when I pick the peaks, we missed one peak. 9.2, 120, so that one. I will add that peak. And then I'll just click on assign and to set up MR residue again, I think. All right, so then that peak get automatically added to the peak list. So this is actually helpful. So don't be afraid that, I didn't pick that peak, so can I make any changes? So that's how you make the change. So you just add that peak and do assign and set up MR residue again. And then that peak will get added to your peak list. Okay, so now we will add the 3D spectrum. So we will go to that ubiquity data file. And so for this time, I'll just select the sequence file, the CBCACONH, HNCACO, and HNCO, and I load all of them. So I'll drag them into the sidebar. And so now all the other 3D spectrum are loaded. And then I can also check the sequence that I just loaded. So it's under chains and under MCA. Now we can see that's actually the sequence of your protein. All right, now we will do peak picking for the 3D MR experiments. And we will start with HNCACB and CBCACONH. So I'll first load the HNCACB. And then I will add CBCACONH to the same module of HNCACB. So I just drag it into this same window. And now both these two spectra are displayed. And I will change the color of the spectrum and go to contours. For HNCACB, I'll keep the positive red, negative green. And for CBCACONH, I'll change the positive peak to blue. And I will not show negative contours for the CBCACONH. Like, okay. And now we can change the contour levels of the peak one by one, because usually the peaks in the CBCACONH are more strong. So first we will work on HNCACB. All right. And then go to CBCACONH. Okay. And now display both, so they are overlaid in one module. And on the right side, I'll just have the HSQC displayed. Then I will go to assign and click on pick and assign. And in this pop-up window, I will go to settings. And here it will ask what peak you want to, in which spectrum you want to pick the peaks. So here I will select the spectrum in this 3D HCM module. And then I'll click on the gear icon again to close the setting window, and then move this pick and assign module to the lower right. Okay. And also I'll go to assign and open up AMR Atom Assigner. And this one is actually used to assign the alpha and beta carbons in your spectrum. Also, I'll move it to the lower right. So now we can work on picking of the 3D HSQC, 3D and its spectrum. And so for those 3D spectrum, you can ask the program just to automatically pick every peak. So I think if you go to spectrum, click on pick, and click on pick ND peaks, then the program will automatically pick every peak in the spectrum that is currently displayed. But this is actually not very helpful, will not save you time, because still you have to go through the peaks that are picked by the program one by one, remove noise and remove artifacts, and make sure the assignment you make is correct. So instead of ask the program to do it automatically, we can actually do it semi-automatically. So you will manually check those peaks that are picked by the program. So what we do is, for example, on this pick and assign module, we first go to pick number 1. So we double click number 1. And then in this HSQC window, if you zoom in, you can see that it automatically navigated to this number 1 peak. And also in this 3D HCM module, it automatically navigated to the peak, which had the same amide proton and nitrogen chemical shift as this number 1 HSQ in the HSQC spectrum. And now I think we need to also change the contour levels a little bit to display all those spectra in HNCACB. Okay, so that's the 4 peaks that we're looking at. And then I will click on restricted pick and assign. So now the program automatically picked those peaks. And also what it did is that it assigned the residue number and atom type, which is amide proton nitrogen, which we assigned from the HSQC spectrum. So it transferred those assignments to the HNCACB and CBCACONH. And then what we need to do now is to identify the alpha and the beta carbon from the previous and current residue, and also assign those atoms. So for example, I know that in this CBCACONH, the alpha and the beta carbon of this previous residue show up. So this cross peak belongs to the alpha carbon of the previous residue, which is CAI-1. I'll just assign it. And now on the peak label, you see now we have amide proton nitrogen and CAI-1. And then I go to the beta carbon and then assign CBI-1 to this peak. All right, so I'll do the other 2. This one is from C alpha because it's present in the HNCACB spectrum. And that green peak belongs to the beta carbon. And there's an extra peak here that must be noise. So I can actually delete that peak. Okay. And then if you look at the peaks in your pick and assign module and look at the AMR atoms, now for residue number 1, you have alpha, beta, amide proton, amide nitrogen, and all those peaks all those atoms are assigned to a peak. So that's your peak picking for the 3D MR spectrum. And we can do another one as an example. For example, if I go to number 3, and also it automatically navigated to these strips in HNCACB and CBCACONH. Again, I need to adjust the contour levels a little bit. And now we're looking at those 4 peaks over here. And then I'll click on restricted peak and assign. And now those peaks get picked up. And then again, I'll just assign the alpha and beta carbons. So I know this is a typical surrounding chemical shift. So I will assign that to CAI-1. this is the beta say beta I-1. And then that peak belongs to say alpha, and this peak belongs to say beta. And again, you see there's some noise get picked up, so we can just delete that peak. And okay. So it will just continue for every residue until for all those residues you have alpha carbon, beta carbon, amide proton, amide nitrogen assigned. So that's for assigning HNCACB and CBCACONH for the peak picking. And then we can work on HNCO and HNCACO as an example. So now I can add HNCACO and HNCO to this same module. And just for clarity, I will remove HNCACB and CBCACONH. And then I go to the region where carbonyl carbon will show up over here. I adjust the contour levels and can adjust the contour levels one by one. So first HNCO, which the peaks are very strong, and then HNCACO, the peaks are little, compared to HNCO, the peaks are weaker. Now we can overlay these two. And again, we'll just do pick and assign. So go to number 1, double click, and then restricted pick and assign. Right, so now those carbonyl carbon peaks are picked. Again, they have those residue number, amide proton, and nitrogen that are transferred from the HSQC. And now we'll just need to identify the carbonyl carbon type. So this one, the green ones, they are present in HNCACO only. So they are the carbonyl carbon of the current residue. And then the blue ones, the carbonyl carbons of the previous residue. So after the carbonyl carbon peaks are picked, then for residue 1, now you have 5 atoms. So carbonyl, alpha carbon, beta carbon, amide proton, and amide nitrogen. And again, you will just continue until for all those residues you have the peak picked. So peak picking is actually very time consuming, especially if you have like hundreds of residues. So that's actually the most time consuming part for backbone assignment. So I'm not going to go through every peak in this workshop. So I have a project that I say, okay, and we'll start from where I opened the project. So in this project, I already assigned, already picked the peaks in HNC, CB, and CBCACONH. And also let me make sure that, yeah, so we are recording. Okay. So I picked all of the peaks. So if you go to assign and select peak and assign, I just want to show you how this look like. So for each cross peak, I have the alpha and the beta carbon atom picked, or they're already in the list. And then I arrange the modules in a way that in the first module, I have a HNCACB and CBCACONH spectrum displayed. And then in the second module, this is exactly the same as the first module. I also have HNCACB and CBCACONH displayed. And in the third module, I have HSQC. So once you arrange the module in this way, then you can do backbone assignment. So we can go to assign and click on backbone assignment. And then I go to settings. And first I would deselect show sequential strips. And then in the match spectrum display, I will select 3DHCN1, which is the second module in the drop area. And then in the search spectrum, so we have all those spectrum arranged. We open the backbone assignment module and we open the sequence graph at the bottom. And now we can start the backbone assignment. And you can randomly start with any residues that you are interested in. Or if you know some residues that have distinctive chemical shapes like glycine, aniline, you can also start with those residues. And for example, over here, I will start with number 17. So I just double click on number 17. And now, so in this HSQC module, you see already shows you that we are looking at number 17 here. And then in this first module, HNCACB and CBCACONH, I will deselect CBCACONH and only show HNCACB. And in the second module, I will deselect HNCACB and just show CBCACONH. So now what the program is doing is that for residue number 17, it will search for the 17 alpha and the beta carbon. So it identified the alpha carbon cross peak and the beta carbon cross peak. And then it will search for any match in the CBCACONH spectrum. As you can see here, it found several matches, 13, 23, and 19. And for each of them, it gave the score, a match score. So this 13 is 99%, 23 is 94%, and 19 is 91%. So that tells me 13 is the correct one. So it's I+1 residue to 17. And then it has a 99% match. So now I can link 13 to 17. So what I'll do is I'll click on 13 and drag it into this orange arrow. That's the I+1 arrow. And let me do it again. So now it's connecting 17 to 13. And then this first module automatically navigate to 13 again and identify the alpha and the beta carbon. Again, then the program search for any match in CBCACONH spectrum. And again, it finds several matches. And the first one always have the highest match score. So then I will collect them. So I collect 9 to 13. So we'll just continue. So now 23 to 9. And then 76 to 23. And now I have come to a point that for residue 76, this is actually the glycine. In the CBCACONH spectrum, the program finds 3 matches, and all of them have 99% match. So I'll have to stop now because now I cannot assign unambiguously. So I'll stop here, and then I will check the chains that I just linked together. So I go to backbone assignment module, click on the chain, which is now number 2. And now you can see that's 9, 13, 17, 23, 76. So that's the residue that I just linked together. And then I can go to the sequence graph. I will move the sequence graph up. And also I will select AMR chain number 2. And that's the chain we just linked. And then in this sequence of the protein, as you can see, the program automatically identified a stretch of sequence, which is LRG, that matches the residues that we just linked together. So now I can make the assignment. So number 17 would be losing 71. So it will ask if you want to make the assignment. I'll do yes. And now the chain disappeared. So now this chain renamed to NCA. And then for this chain, instead of having just a residue number, now it have the residue type leucine, and it's a 71 in your protein sequence. And then we can go back to the backbone assignment module, and now you see all those residues now have a type and a sequence number. So that's how to do the backbone assignment. And this is in the I+1 direction. And as you can see, while I do it in the I+1 direction, there at some point I have to stop because I can't make the assignment unambiguously. So we can actually do the assignment in the I-1 directions to see if we can remove the ambiguity. So an example is that in the I-1 direction, then in the first window, I'll select CBCACONH. And in the second module, I select HNCACB. And now I will go back to the original chain. And if you want to do the assignment in the I-1 direction, then you need to start with the residues that are labeled as the residue number -1, like this, 1 -1, 2 -1. And these are automatically generated while you pick the peaks in this 3D spectrum. So for example, here I will start with 94. So I double click on that. And then in this first module, now we are displaying CBCACONH. So it also, this program find that there's 2 cross peaks in the CBCACONH. And then in the search module, which is the second module, now it's trying to identify if there's any cross peaks in the HNCACB that matches those in the CBCACONH. And then also I need to increase the peak level a little bit because the peaks are weaker in the HNCACB. Okay, so now this shows that it finds the match. So 28 has a 99% match. And also it tells you it's in the I-1 residue. So now we can link those 28. And now we will link it to the I-1 arrow and collect those residues. And again, and just to continue in this way. And number 1 and 102. And next is 108. All right, so I think next is 57. And now again, for 110, now the program find 2 matches, 105 and 39 in HNCACB spectrum. And both of them have 98% match. So also again, I come to the assignment unambiguously now. So I'll stop over here. And then I go to this chain that we just linked. Now it's called AMR chain number 4. So here, that's the chain that we just linked together. Now you can go to the sequence graph again, select the chain that we just linked, and again, check if you can identify any residues. And you can see the program identified this stretch of sequence. So now we can just do the assignment and click on yes. All right, so now you see for all those residues that we just assigned, it turns to green. So we have 2 stretches of sequence that we just assigned. And then all of them are combined into that AMR chain A. So now we have more residues assigned. So we can just continue in this way. And if you cannot assign all of them just based on HNCACB and CBCACONH, then you can use HNCO and HNCACO. And the process is exactly the same. So you display HNCO and HNCACO, and then do the assignment in I+1 direction and I-1 direction. And that also can be used to correct some of your assignment and also remove some ambiguity in your assignment. And finally, if you want to check the assignment of all of your residues, you can actually go to Assign under Assignment Inspector. And then that will open up the Assignment Inspector window where you can just check every assignment. And if you find that, okay, I want to make some modifications, then you can just click on write, and then you can edit the assignment. Okay. All right. So that's all for how to do the backbone assignment. And using this CCPNMR, it makes the assignment much more easier. I've done this previously just manually, and it takes a very long time. But now using this software, you can do it semi-automatically, and that saves you time.